Hello guys, in this lesson I'm going to talk about laws of indices. Indices is a plural of index. An index is a small number that tells us how many times a term has been multiplied by itself. For example, if we have a number 4 and 3, in this case 4 is known as the base and 3 is known as the index. Therefore, we can read this as 4 to the power of 3. So 4 to the power of 3 or 3. So 4 to the power of 3. Since index is a number that tells us how many times a term has been multiplied by itself, another way of expressing 4 to the power of 3 is, we can say this 4 to the power of 3, we can express it as 4 times 4 times 4. We can see that 4 is multiplied by itself 3 times, and this will give us 64. Another way of writing, we said index notation. And this index notation is a method of shortening the product of numbers of equal factors or numbers that are the same. For example, we have 2 times 2 times 2 times 2 times 2. We can say in a short form 2 raised to the power 5. Or if you have 7 times 7 times 7 times 7, in short, we can say 7 raised to the power 4. So generally, if we have a times a times a times a, this will be a raised to the power 4. The a is called the base, while this 4 is known as the index. Alright, there are basically 8 laws of indices, and we are going to discuss each law in detail. The first law of indices is the law of multiplication. The multiplication law. This law states that when numbers with equal bases are being multiplied, their power or their indices are added. So, for example, you have a raised to the power x times a raised to the power y. Since these ones are the bases and they are the same, we can say a raised to the power x plus y. We'll simply add the powers. Remember, in our introduction we said that these are the bases while these are the powers, or these are the indices, or the index of this one is x and the index of this one is y. So we simply add the powers since the bases are the same. So using a real example, if you have 2 raised to the power 2 times 2 raised to the power 3, is something as saying since the bases are the same, we use 2 raised to the power 2 plus 3, giving us 2 raised to the power 5, and 2 raised to the power 5 is something as 32. So it will be better than saying this side is 2 times 2, then we have our multiplication times 2 times 2 times 2. You can see that is actually low, very long. So that's the best way of using law of indices, because it shortens some of the long way of doing things. But if two groups of factors of different numbers are multiplied, the different factors are collected as one group to give the product. So, for example, if we have 2 times 2 times 3 times 2 times 3, what I'm going to do, we can see we have 2, 2, and 2 here. We can bring these two together, and these 3 and these 3, we bring them together. We're going to have 2 times 2 times 2. Then we have times 3 times 3. Remember that these ones here are what, having the same basis. So it's something as saying 2 raised to power 3 times 3 raised to power 2. Can you see? Or if we have something like 2 raised to power 3 times 3 raised to power 2 times 2 raised to power 3 times 3 raised to power 2. What I'm going to do, we're going to bring these 2 and these 2 together, giving us 2 raised to power 3 times 2 raised to power 3. Then bringing these 3 and these 3 together, we have 3 raised to power 2 times 3 raised to power 2. And this is something as saying 2 raised to power 3 plus 3 times 3 raised to power 2 plus 2. Why? Because these and these have the same base. Therefore, we'll add this power and this power. That's why we can see this. Then this one here, we add this power and this power, giving us this. So now we can say that we have something like this. 2 raised to power 6 times 3 raised to power 4. So that's it. So if you have two groups of factors, that is of different numbers, are multiplied, the different factors are collected as one group to give the product. The second law is the division law. Division law. And the law states that when dividing numbers with equal bases, the power of the divisor is subtracted from that of the dividend. Now, when you have, for example, you have a raised to power x divided by a raised to power y, since they have the same basis, and this is the dividend and this is the divisor, we're going to say the same thing as saying a raised to power x minus y. So in real example now, when we have 2 raised to power 3 divided by 2 raised to power 2, since the bases are the same, we can just simply subtract the powers, giving us 2 raised to power 1, which same thing as 2. Now, another way of proving this is by simply saying, since we have 2 raised to power 3 divided by 2 raised to power 2, we can simply say 2 raised to power 3 divided by 2 raised to power 2. And another way of writing this is same thing as 2 times 2 times 2 over 2 times 2. So these two can cancel these two. We are left with only 2. And you see, this is same thing with this, but this is more shorter. So that is actually the power of the law of indices. So generally, if you have the same basis having power, you can simply what, subtract the powers. The third law is the power law. The power law. And it says that if a number which is raised to a certain power is again raised to another power, it is said to be in powers. Then the two powers are then multiplied together for the final result. So now, if you have a is raised to the power of x and is raised to another power of y. The simple thing to do here is to simply just what? Multiply the power x times y, right? So, for example, if you have a number 2 raised to power 3 and to the power of 2. The simplest way to do is to say 2 raised to power, this 3 will multiply by this 2. 3 times 2, giving us 2 raised to power 6, right? And 2 raised to power 6 is 64. So generally, if a number is raised to a power and is raised to another power, then the two powers can simply multiply by each other to give you something like this. The fourth law is the product power law. Product power law. And this said that when the product of different factors are raised to a certain power, perhaps in a bracket, the power is distributed over each factor in the bracket. So, for example, if you have two numbers in a bracket raised to a power of x, this x is distributed, or it will be distributed to the numbers in this bracket. Remember that any number that is on its own is having invisible 1 to the power of 1. So this x will now multiply by the numbers or by the power of the numbers in this bracket, giving you something like a raised to power 1 times x, b raised to power 1 times x. Remember the third law, the power law, which says that anything that we have here can actually multiply by what is outside the bracket. So giving you something like a raised to power x, b raised to power x. So using an example now, if we have 3pq to the power of 2, these two now will be distributed to the numbers in this bracket. Each of these is having an invisible power. So multiplying this by each power of the number inside the bracket is going to be 3 raised to power 1 times 2. Then we have p raised to power, this 1 times this 2, 1 times 2, and q raised to power 1 times 2, giving us 3 raised to power 2, p raised to power 2, and q raised to power 2. 3 raised to power 2 is 9, and p raised to power 2, q raised to power 2. So whenever the product of different factors are raised to a certain power in the bracket, this power is being distributed to the power of the numbers in the bracket. All right, the fifth law is the zero index, the zero index law. The zero index law. And this law says that any number to the power of 0 is always equals to 1. So if you have any number to the power of 0, it will always be equals to 1. Even if it is 100 to the power of 0, it will always be equals to 1. So let's see, for example, if we have 2 raised to power 2 divided by 2 raised to power 2. Using the second law of indices, we say that whenever we have bases that are the same, we simply subtract the power. So we have 2 raised to power 2 minus 2, giving us 2 raised to power 0. And anything raised to power 0 based on the zero index law is 1. So anything raised to power 0, it will always give you the result of 1. The next law, which is the sixth law, is the negative index law. Negative index law. And this law says that whenever a number is raised to a negative index, it will always be equal to the reciprocal raised to the same positive index. So, for example, if you have a raised to power negative index, this negative now, it will give you the reciprocal. And you see, this 1 over is from this minus, this negative sign. Then raised to power this base to the power of x, a to the power of x. Okay, so if we have 2 raised to power minus 2 is something as saying the reciprocal of 2 raised to the power of 2. So this negative number, this negative sign will give you this reciprocal. Then these 2 raised to power, this base to the power of 2 will always be at the bottom. So giving you 1 all over anything raised 2 raised to power 2 is 4. So giving you 1 over 4. Another example here is when you have 3 raised to power minus 2 will always give you this minus sign will be 1 over then 3 raised to power 2, which is same as 1 all over 3 raised to power 2 is 9. 1 over 9. The seventh law is the roots power law. 7 roots power law. And this law involves the method of showing the indices of different roots, and these may include square roots, cube roots, fourth root, and this law said that whenever a number is raised to the power of a fraction, most especially 1 over a certain number, this simply becomes the root. So this one will give you the x root of a, right? So if we have 4 to the power of 1 over 2, this becomes the root, and it will give you the square root of 4, because no need of writing the 2 here, because automatically this is already in square root, and the square root of 4 is 2. Another example is if we have 16 to the power of 1 over 2 is same thing as saying the square root of 16, which is 4. Another good example again is when you have 27 to the power of 1 over 3. It's same thing as saying the cube root of 27, which is 3. Or we can say when we have 16 to the power of 1 over 4, which is same thing as the fourth root of 16, which is 2. The last law is the fraction index law. That is it. Fraction index law. Remember that in the seventh law, which is the roots power, we said that whenever a number is raised to a half, this one will always be the root, which will be the x root of a. Now, at times a number might be raised to the power which is fraction other than half. The method of resolving this is by finding the value of root of the denominator and later raising the outcome to the power of the numerator. So if in this case you have a raised to power x over y, now this now will be the root and this one will be the power. So it will now be the y root of a to the power of x. That's the meaning of this law. So for example now, if we have a number like 4 to the power of 3 over 2, so this becomes a root and this becomes a power. So we'll have the square root of 4 to the power of 3. What is the square root of 4? Is 2 to the power of 3, giving you 8. Right? Another good example using this law is 8 to the power of 4 over 3. And we said this becomes a root and this becomes a power, which is same thing as the cube root of 8 to the power of 4. And the cube root of 8 is 2 to the power of 4 is 16. So in the next section, we are going to solve a lot of problems using the laws we have studied. Okay, till then, see you in the next lesson. Thanks for watching. Hello guys. In our previous lesson, we've learned about the various laws of indices. And this time around, we're going to apply those laws to solve some problems. But one thing to put in mind here is that whenever a question is given, the laws to be used will not be stated. It's now left for you to know which one to use and how to use it. Keep it in mind that some problems demand the application of more than one law. I'm going to split the videos. In this video, I'm going to look at the simple and easy questions. Then in the next lesson, we're going to look at more complex problems. Alright, we have the first question. 2 raised to power 2 times 2 raised to power 2 times 2 raised to power 4. And we know from the first law, it says that whenever we have any base that are the same, we simply add the powers since it is multiplication. So in this case, we're going to say 2 raised to power 2 plus 2 plus 4. We're going to simply add the powers. So which is going to give us 2 raised to power 8. And 2 raised to power 8 is equals to 256. That's the first question. The second question is 4m square n multiplied by 5m n less than minus 6. So now in this case, you can, if you notice it, that this 4 and this 5 are not the same. Since the bases are not the same, we're going to multiply them together. So we said 4 times 5, and since m has the same base with this m, so we're going to bring them together using the addition law. Since they have the same base, we simply add the powers. Remember that whenever a number or an alphabet exists on its own, is having invisible one. For example, when you have a, there's an invisible raised to power 1 here. So in this case, we're going to say that this m here is raised to power 1. So we'll have m raised to power 2 plus 1. Then we have the n raised to power 1 plus negative 6. So in this case, 4 times 5 is 20. Then m raised to power 2 plus 1 is 3. Then n 1 negative times positive is what? Negative 6, giving us 20m cubed, and 1 minus 6 is minus 5. So in this case now, we can say that's our answer. But if you want to take it further using the power of negative a low, we're going to say this one here is going to be 20 m raised to power 3, and this minus n, it means with, remember the law that whenever anything is raised to power negative value, is the same thing as the reciprocal of that value to the power of number. So this one we say times 1 over n raised to power 5. So this minus sign here, give rise to this reciprocal function. So in this case, we're going to say this is balance 1 with 1, going to give us 20m, this 20m square cube rather times 1 is 20m cube over n raised to power 5. So, but you can solve it from here. But if you want to take it further, you can take it up to this point. Right, the third question is 8 raised to power 1 over 3. Remember that whenever a number is to the power of 5, this becomes the root. So this is the cube root of 8. We're going to say the cube root of 8. And the cube root of 8 is 2. That is, what is that number that we're going to multiply it 3 times that will give you 8? Remember, by the time you say 2 times 2 times 2 is going to give you 8. So that's why we say the cube root of 8 is 2. So that's our answer. The fourth question is 81 to the power of 3 over 4. Remember that this one becomes the root and this becomes the power. So in this case now, we're going to have the fourth root of 81 to the power of 3. So what is the fourth root of 81? What are we going to multiply 4 times to give us 81? Is what? 3. Remember that 3 times 3 times 3 times 3 is equal to 81. Therefore, we can say that this is the fourth root of 81 is 3. So it's going to be 3. Remember that we still have our power here to the power of 3. And 3 to the power of 3 is 27. Right? Right, the next question we have here is 27. That's the fifth question. 27 to the power of negative 2 over 3. Now, remember that when you have something like this, there is a negative power here. What are you going to do? You're going to take the reciprocal 1 over 27 to the power of 2 over 3. But don't forget that this one will always be the root and this will always be the power. So we're going to have 1 over the cube root of 27 to the power of 2. So what is the cube root of 27? What are we going to multiply 3 times to give us 27? We're going to multiply 3 times 3 times 3 will give us 27. So the cube root of 27 is 3. Remember, we still have this power, which is the power of 2. And therefore, 3 to the power of 2 is 9. So our answer is 1 over 9. Right. The sixth question is 64 to the power of 5 over 6. So this becomes the root and this becomes the power. So in this case, we're going to say the sixth root of 64 to the power of 5. So what are we going to multiply 6 times to give us 64? But the number is 2. So 2 times 2 times 2 times 2 times 2 times 2 times 2 will always give us 64. So the sixth root of 64 is 2. Remember, we still have the power here, which is 5. So 2 to the power of 5 is 32. So that's our answer. The next question is number 7, which is 16 over 81 to the power of 3 over 4. So I'm going to pause the video here, give it a try, then we'll solve it and see. Alright, let's give it a try. As we know that this one here becomes the root and this becomes the power, right? So in this case, we're going to have the fourth root of 16 over 81 to the power of 3. So remember that this is a fraction. So we're going to have, what is the fourth root of 16? What are we going to multiply 4 times to give us 16? It is what? 2 over. What are we going to multiply 4 times to give us 81? That's 3. So 3. Remember, we still have our power here. So the power of 3. So in this case, this power is for both 2 and 3. In this case, we're going to distribute this power to both of them. We have 2 raised to the power 3 over 3 raised to the power 3, which is same thing as 2 raised to the power 3 is 8, and 3 raised to the power 3 is 27. So that's our answer. Right, next question is when we have b to the power of 2 over 3 all to the power of 12. How are we going to solve this? In this case, we are aware that when we have anything x raised to the power a into b, this power will simply multiply by each other, which will be x raised to the power ab. So in this case, we're going to multiply this 12 by this 2 over 3. So we're going to have b raised to the power 2 over 3 times 12. Then let's balance on with 1. So 3 here is 1, 3 here is 4. Having b raised to the power 2 as an answer. Right, another question here is 1 over 3 to the power of 5n multiplied by 9 to the power of n minus 1 multiplied by 27 to the power of n plus 1. Now, in this case now, you know that this 3 is the smallest number and this 9 is associated to this 3. If you multiply 3 twice, you're going to get 9. And if you multiply this 3 thrice, you're going to get 27. So in this case, we're going to make this in the power of 2. That's 3 to the power of 2. And this 3 to the power of 3. So that all of them will be in the base of 3. So we have 1 over 3 to the power of 5n times 3 to the power of 2 to the power of n minus 1 times 3 to the power of 3 n plus 1. So multiplying the inner bracket to the ones outside, remember that when you have anything x raised to the power a times b is going to be x a b, right? So it will be 1 over 3 raised to the power 5n times 3 raised to the power 2. This 2 times n is going to be 2n minus 2 times 1 is going to be 2. Then times 3 times n is 3 raised to the power 3n. Then 3 times 1 is plus 3. So now this one here is in the form 1 all over a, and a raised to the power x, and we can make it a raised to the power minus x. So in that case, we'll have 3 to the power of 5n raised to power minus 1, right? This reciprocal will turn it to be minus 1 times 3 to the 3 to the power of 2n minus 2 times 3 to the power of 3n plus 3. Now, we multiply this by this minus 1. We'll be left with 3 to the power of minus 5n, because minus 1 times n minus 5n times 5n is going to be minus 5n. Then we have times 3 to the power of 2n plus 2 times 3 to the power of 3n plus 3. Now, if you will notice it, all are the same basis. What we're going to do, and remember, it's multiplication, we're going to simply add the powers. So if we add the powers now, we're going to have something like 3 to the power of minus 5n plus 2n minus 2 plus 3n plus 3. Remember that this plus this one here is from this multiplication, and this one is from this multiplication. So if you collect items, we're going to have 3 to the power of minus 5n plus 2n, then we have plus 3n here, plus 3n, then we have minus 2 plus 3. We've collected items. So minus 5n plus 2n, using number line, you're going to have minus 3, and minus 3 plus 3 is 0. So we'll have 3 raised to power 0, then minus 2 plus 3 is 1. So we're going to have plus 1, giving us 3 to the power of 1, which is equals to 3. Right, the next question is 343 divide 125 all to the power of minus 1 over 3. Remember the laws that say that whenever we have anything raised to the power of a negative number, is going to give us the reciprocal of that number to that power. So now this one here is going to be 1 all over 343 over 125 to the power of 1 over 3. So this is same as saying the roots here. Okay, so we're going to have 1 all over the cube root of 343 over 125. So this here will be 1 all over, what is the cube root of 343? It is 7. And the cube root of 125 is 5. So we're going to have this. Remember that this one here, multiply the numerator, will be left with 1 all over 1 times 5 rather over 7, giving us 5 over 7 as the answer. So don't be confused. This one here can simply multiply by this. That's why you can see this here. The next question we have here is 64 over 729 all to the power of minus 2 over 3. Remember that any number to the power of a negative value will always give us a reciprocal of that number to its power, right? So that means this one is going to be 1 all over 64 over 729 all to the power of 2 over 3, which will be, this one will be the root and this one will be the power, right? So if that's the case, we'll have 1 all over the cube root of 64 all over 729 to the power of 2. So what we're going to have, we're going to have 1 all over, what is the cube root of 64? The cube root of 64 is 4. So we have 4 all over. The cube root of 729 is 9. So we have 9 all to the power. Remember, we still have the power of 2. So in this case, the answer is going to be 1 all over. What is the square of 4? Because this square now will be distributed. Remember, when we have anything x raised by a to the power of b, this will multiply by this. So also this one will be distributed among this. So we have 4 square all over 9 square. And 4 square is usually what? The 4 square is 16. So we have 1 all over 16 over 9 square is 81. 81. So this one will simply multiply by this. So we'll be having 81 all over 16. And 81 all over 16, the answer is 5. It will go 5 times. Remember, 1 over 16. So that's the answer. In our previous lessons, we've been solving problems associated to laws of indices. And in today's lesson, we're going to solve problems associated to law of indices that are decimal powers and bases. Sometimes the power or base of an expression may be in decimal form. The best approach is by converting such decimals to fractions before solving. The final answer may therefore be converted back to decimal. So, for example, if we have 0.25 to the power of minus 2. The first thing we need to understand here is that is converting these to a fraction. How are we going to convert it? Can you see this decimal point? You move it. The number you move is by the number of zeros you divide. You have 1, 2. So you move 2 times. So this one is going to be 25 all over now 1, 2 zeros because you move twice. So to the power of minus 2. So 25 here is 1, 25 here is 4. So we're going to have 1 over 4 to the power of negative 2. And remember that whenever we have a number to the power of a negative power, is going to be the reciprocal of that number to the power. So if that's the case, we're going to say 1 over 4 to the power of 2, which will give us 1 all over, distribute this power to 1 and to 4. So we're going to have 1 all over 4 square is 16. So taking this one to multiply the numerator, we're going to have 1 times 16 all over 1, which is same thing as 16. So you can see, so converting, having the knowledge about the conversion of decimals to fraction is very paramount in this type of situation. So for example, now let me explain something here. If you have 2.5, you want to convert it to fraction, what are you going to do? You see this decimal point, you move once. So since you move once now, it's going to be 25 all over now 10 because you move it once, which is 5 here is 5 and 5 here is 2, giving you 5 over 2. So that's a fraction. Another example that involves decimal is 32 to the power of 0.2. In this case, we're going to convert the power to fraction. So it's going to be 32. So this one here will move once, right? So if you move once, it's going to be 2 all over 10 because it moved once. So 2 here is 1, 2 here is 5, which is going to be 32 to the power of 1 over 5. So remember that this one becomes what? The root, right? So it's going to be the fifth root of 32. And what is the fifth root of 32? That's what I'm going to multiply 5 times to give you 32. It is what? It's a 2 times 2 times 2 times 2 times 2. 5 times is going to give us 32. So the answer is 2. Another example is 0.008 to the power of 1 over 3. So converting this, we're going to move this 1, 2, 3. So it's going to be 8 all over 1, 2, 3. So to the power of 1 over 3. So if you will divide this, 8 here is 1. 8 into 1000 is 125. So we're going to have 1 all over 125 to the power of 1 over 3. So remember that this is what? The root, right? Becomes a root. So which is the cube root of 1 all over 125. So what is the cube root of 1? Is same thing as 1. And the cube root of 125 is same thing as 25. So, and this will be our answer. Very, very simple, right? Okay, another question that I have to do with decimal is 0.25 to the power of minus 1 over 2. So converting 0.25 is going to be move this on 1, 2. So say 25 divided by 1, 2, all to the power of minus 1 over 2. So in this case, this one here can go 1, and this one here can go 4 times, right? So we are left with 1 over 4 to the power of negative half. So when you have a negative power now, you know it's going to be the reciprocal of 1 over 4 to the power of half. Remember, this one is the what? Root, right? So we're going to have 1 over the square root of 1 over 4. And the square root of 1 over 4 is going to be 1 all over the square root of 1 is 1, and the square root of 4 is 2. So this one will move here. We're going to have 2 as the answer. Hello guys, in this lesson I'm going to talk about law of indices that have to do with exponential functions. When an unknown is the index or power of a function, that is a number, then it is an exponential function. So for example now, when we have a number like this, 3 raised to power x is equals to 9. So we can see that the index now is an unknown. So we can say that this is an exponential function, and as a result of that, solving it is not hard. What you need to do here is to check the lowest possible number. So the lowest possible number in the equation is 3. So how many times are you going to multiply this 3 to give us 9? You know you're going to multiply 3 twice to give you 9. So which is going to be 3 raised to power x is equals to 3 raised to power 2. So now what you need to do is that you just to equate the base, and you're left with only the power. So we can say that x is equals to 2. As easy as that. So we're going to see some questions that have to do with exponential function in law of indices. One of such problem that have to do with exponential function is 2x is equals to 64. So as we said, the smallest number here is 2. So how many times are you going to multiply 2 to give us 64? which is 6 times. So we're going to say 2 raised power x is equals to 2 raised power 6. You can see the base are now the same, right? So you equate them. So you're left with what? X is equals to 6. So that's the answer. Another good example here is that when you have 5 raised by x plus 1 is equals to 625. So now the smallest number here is 5. So how many times are you going to multiply 5 to give you 625? Which is 4 times, because 5 times 5 times out. If you multiply it 4 times, you're going to have 625. So in this case, we're going to say 5 raised by x plus 1 is equal to 5 to the power of 4. So the base are the same. You equate the base. By the time you equate the base, you have left with x plus 1 is equal to 4. Now this one here, collecting like terms, we're going to have x equals to 4 minus 1. So x is equal to 3. Right? The next question we're having is 4 raised by x is equal to 1 all over 1024. So we are aware that when you have x raised by minus a is same thing as saying 1 all over x raised by a. So you can move it from this form to this form, and you can also write back to this form. So in this case, we can say 4 raised by a is same thing as 1024 to the power of minus 1. So it's the same thing but in different form. So in this case now, how many times are you going to multiply 4 to give you 1024? So we know that if you multiply 4 5 times, you're going to get it. So it's going to be 4 raised by x is equals to 4 raised power 5. Remember, you have minus 1. And remember the law that says that whenever you have x raised by a to the power of b is going to same thing as saying x raised by ab. So this 5 here is going to multiply this minus 1. So we have 4 raised by x same thing as 4 raised by minus 5. So equate it. By the time you equate it, because they have the same base, we can say that x is equal to minus 5. Another question, when you have 32 raised by x is equal to 0.25. This question is a combination of decimal and exponential function. So we're going to convert these to a fraction. And in the last lesson, we've seen how you convert this to fraction by moving this decimal point 1, 2. So in this case, we're going to have 32 raised by x equals to 25 over 100. So 25 here is 1 and 25 here is 4. So we have 32 raised by x is equal to 1 over 4. And remember that x raised by minus a is same thing as 1 over x raised by a. So therefore, we can write this one here as 32x equals to 4 raised by minus 1. So now the lowest possible number here is 2, even though 2 is not here. The lowest multiple is 2. So we can say that 2 raised by this one here is 2 raised by 5 will give us 32. So 2 raised by 5 multiplied by x, right, is equal to 2 raised by 2, because this 4 will give you 2 raised by 2 to the power of this minus 1. So 5 times x is what? 5x. So we have, let me take it to this side. We have 2 raised by 5x is equals to 2 raised by minus 1, minus 2 rather, sorry, minus 2, because 2 times minus 1 is going to give us minus 2. So now the bases are the same, right? The bases are the same. Let me clean this base. the bases are the same. So if that is the case, since the bases are the same, we equate it. We have 5x is equals to minus 2. Divide both sides by 5. So our x is equals to minus 2 over 5. So that's the answer. Is 10 minus x is equals to 0.0001. So converting this one to fraction now, we move 1, 2, 3, 4. So we're going to say 10 raised to power minus x equals to 1 over 1, 2, 3, 4. So now converting this one now from 1 over 8 is to a raised to power minus 1. Same as saying 10 raised to power minus x is equals to 1, 2, 3, 4 to the power of minus 1. And this one here, the same thing as saying 10 times 10 times 10 times 10 to 4 places. If you multiply 10 in 4 places, you're going to have this. So we're going to have 10 raised to power minus x equals to 10 raised to power 4 to the power of minus 1. So remember that when you have x raised to power a to the power of b, same time as x raised to power a b, right? So in this case now, we are going to use the same method to solve this. We say that now we have 10 raised to power x, 10 raised to power minus x is equals to 4 times minus 1 is going to give us 10 raised to power minus 4. So equate the base, you are left with minus x is equals to minus 4. So divide both sides by minus 1. Minus 1. Minus can cancel this. You have, so our x now is equals to 4 because this minus cancels this minus 1. So we have, so that's the answer. Next question. Next question we have 16x is equals to 0.25. So I'm going to pause the videos, try solving it and see. Okay, now let's try. We'll convert this one to fraction first. So it's going to be 16x is equals to 25 divided by 100. So 25 here is 1, 25 into here is 4. So we are left with 16x is equals to 1 over 4. So converting it from 1 over a to a raised to power minus 1. So we're going to use that. It will be this one here. It will be 16x is equals to 4 raised to power minus 1. So how many times are you going to multiply 4 to give us 16? That's 2 times. So 4 raised to power 2 is 16 to the power of x is equals to 4 to the power of minus 1. So 2 times x is going to be 4 raised to power 2x equals to 4 raised to power minus 1. So equate the base. We're going to have 2x equals to minus 1. Divide both sides by 2. Our x now is equals to minus 1 over 2. Another question is, when you have 4 raised to power x is equals to 1 all over 32 to the power of 1 minus x. So in this case now, how are we going to approach this problem? We're going to approach this problem by converting all to the lowest possible number, possible multiple, that's 2. So now in this case now we will have 2 raised to power 2 to the power of x is equals to 1 all over 2 to the power of 5 all raised to power 1 minus x, right? So this one here, if you multiply this by this, we'll have what? 2 raised to power 2x equals to 1 all over 2 raised to power 5 times 1 is 5. 5 times x is minus 5x. So in this case, we can say that converting this one here, we have 2 raised to power 2x is equal to 2 raised to power 5 minus 5x to the power of minus 1, right? So now this one is going to be 2 raised to power 2x equals to 5 times minus 1 is minus 5. Minus 5 times minus 1 is going to be plus 5x, right? So equating the base, we have 2x is equal to minus 5 plus 5x. So this one here is going to be collecting like terms. We have 2x minus 5x is equal to minus 5. So 2 minus 5 is going to be minus 3x equals to minus 5. Divide both sides by minus 3. This cancel this, right? So this minus sign cancel minus sign, and we have therefore x now is equals to 5 divided by 3. It will go 1 time remainder 2 divided by 3. So this answer. Next question is 16 raised to power 3 minus x is equals to 1. Alright, this type of question is simple but it's very tricky. Now, you remember that anything raised to power 0 is always equals to 1. So we will use this as an advantage. So we are going to convert this one, make it to the power of anything that will suit this raised to power 0. So we can say 16 raised to power 3 minus x is equals to 16 raised to power 0, which is equals to 1. So equate the base now, we will left with 3 minus x equals to 0. So collecting items now, we can say that 3 is equals to x, or we say x is equals to 3. So that's another good example is 4 raised to power x times 8 raised to power 2x minus 1 is equals to 1 all over 16 to the power of 1 minus x. So in this case now, the simplest way to go here is to look for the same multiple that will go for this, and this. So what is that? Which is 2. So this 2 raised to power 2 power x again times 2 raised to power 3 to the power of 2x minus 1 is equals to 1 all over 2 raised to power 4 to the power of 1 minus x. So this one here is going to be 2 times x is 2 raised to power 2x times 2 raised to power 3 times 2x is 6x, and 2 times minus 1 is minus 3 is equals to 1 all over 2 raised to power 4 times 1 is 4 minus 4x, right? So in this case, since this one the bases are the same and there is multiplication between them, we are simply going to add them, the powers. So we will say 2 raised to power 2x plus 6x minus 3 is equals to, so converting from 1 all over a is equals to a raised to power minus 1. Now we can say this one is same thing as saying 2 raised to power 4 minus 4x to the power of minus 1, right? So in this case, we can say that 2 raised to power 2x plus 6x minus 3 is equals to, now this minus sign, minus 1 is going to multiply everything. Here we have 2 raised to power minus 4 plus 4x, right? So equating the base now, we are left with 2x plus 6x minus 3 is equals to minus 4 plus 4x. So by the time you collect like times down, we're going to have 2x plus 6x. 2x plus 6x is going to be 8x. Then we have minus 4x 4x is equals to minus 4 plus 3. So 8 minus 4 is going to be 4x equals to minus 4 plus 3 is minus 1. Divide both sides by 4. You have this, cancel this. You have x is equals to minus 1 over 4. So let's solve this. So if 2 raised power 1 minus y times 2 raised power y minus 1 over 2 raised power y plus 2 is equals to 8 raised power 2 minus 3y. So how am I going to solve this? Equate everything, let's make every base to be 2. Since the smallest base here is 2, so how can we do that? We're going to say, and remember that these ones are having the same base, so we can add them, giving us 2 raised power 1 minus y plus y minus 1 over 2y plus 2 is equals to, now 2 raised power 2, is it 2? Sorry, 2 raised power 3 rather, will give us 8. So 2 raised power 3 into 2 minus 3y. So in this case now, remember that this is division, so we can say that 2 raised power 1 minus y plus y minus 1 divided by 2 raised power y plus 2 is equal to, so multiplying this by this, we're going to have 2 raised power 6 minus 9y. So now remember that this minus sign, this one cancel because minus y plus y is 0 and 1 minus 1 is 0. So we'll be having 2 raised power 0 divided by 2 raised power y plus 2 is equals to 2 raised power 6 minus 9y, right? So same thing, since the base are the same, you subtract the power. So we're going to say 2 raised power 0 minus y plus 2 equals to 2 raised power 6 minus 9y. Am I right? So in this case now, if you equate the bases, you're left with minus y plus 2 is equals to 6 minus 9y. Collecting like terms, when I collect like terms, we have minus y plus 9y is equals to 6 minus 2. So minus y plus 9y is going to give us 8y is equals to 6 minus 2 is 4. So divide both sides by 8, cancel. So 4 here is 1, 4 here is 2. So y is equals to 1 over 2. So we have 1 all over 81 to the power of x minus 2 is equals to 27 to the power of 1 minus x. So what is that number that we can multiply it so that this 81 and 27 will have the same base? Remember, 3 can do that, because 3 raised to power 3 is 27 and 3 raised to power 4 is 81. So this one is going to be 1 all over 3 raised to power 4 to the power of x minus 2, right? Is equals to 3 to the power of 3 raised to power 1 minus x. So multiplying the bracket, the power in the bracket to the one outside is going to be 1 all over 3 raised to power 4 times x. It's just like you have a bracket 4x minus 2. You know that this will multiply this and this multiply this, right? So we have 4 times x is 4x, and we have 4 times minus 2 is minus 8. Is equals to multiplying the one inside the bracket to the one outside, simply saying 3 into 1 minus x, right? This multiplied by this. So we have 3 to the power of 3 minus 3x, right? So remember that this is in the form of a 1 all over a to the power of x, and we need to convert it to this form, 1 all over, sorry, this form, a to the power of minus x. So doing that, we are going to have something like this. We're going to have 3 to the power of 4x minus 8 raised to the power minus 1 is equal to 3 raised to the power 3 minus 3x, right? So multiplying the power by this power 2, we're going to have 3 raised to the power. So multiplying the power to this power outside, we're going to have minus 1 times 4x. We're going to have 3 raised to the power minus 4x. Then minus 1 times minus x is going to be plus 8 is equals to 3 raised to the power 3 minus 3x, right? So equate the base. By the time you equate the base, we have the power to be minus 4x plus 8 is equals to 3 minus 3x, right? So collect the items, we have 4 minus 4x plus 3x is equals to 3 minus 8. Am I right? So minus 4 plus 3 is going to be minus x is equals to 3 minus 8 is minus 5. So divide both sides by minus 1, right? So this cancel this minus. So we have x is equals to 5. Alright, I hope with this at least you have a full understanding about the laws of indices. Try to look for problems, solve it, apply it, and try to be comfortable with it. Thanks for watching.